Right, so we're going to be solving some equations here, and for letter A, you're going to be giving me estimates, and for B and C, they're going to be exact values, which means you'll use your unit circle. And since we're doing radians, it's going to be between 0 and 2 pi. All right, so let's start with 7a. I'm going to solve this equation. I'm going to add 1 to both sides, and I get 5 times the cosine of x equals 1. Divide both sides by 5, and I get that the cosine of x equals 0.2, or I can leave it as 1/5. Take the inverse of each side, and I get that x is the inverse cosine of 1/5, or 0.2. So I'm going to need to use my calculator. But before I even do that, I recognize that the cosine is positive, which means both of my answers are going to be on this side of the unit circle. So I'm going to have a quadrant 1 answer, and I'm going to have a quadrant 4 answer. All right. First, I need to make sure my calculator is in radians, and then do inverse cosine. I can either do 1/5 or 0.2, and I get 1.369. So x equals 1.369. That's one of my answers. That would be my quadrant 1 answer. And because this angle is 1.369, to get to my quadrant 4 answer, I'm going to take 2 pi minus the 1.369. So 2 pi minus 1.369, and I get 4.914. Right here. So those are my two answers. All right, let's go to letter B. I'm going to subtract 2 from each side, and I get 4 times the sine squared of x equals 3. And divide both sides by 4, and I get sine squared of x equals 3/4. Take the square root. So sine of x equals plus or minus. I took a square root. I have to do plus or minus. And I get the square root of 3. I don't know what that is. I do know what the square root of 4, though, is. It's 2. So then I take the inverse. X is equal to the inverse sine of plus or minus square root of 3/2. So I need to look on my unit circle for where the y coordinate, sine is y, is positive or negative square root of 3/2. I'm going to get my unit circle. Let's see, my y coordinate is the square root of 3/2 here. And since I want plus or minus, it's going to be where all of my blues are. So I'm going to have pi over 3, 2 pi over 3. Down here I've got negative at 4 pi over 3 and 5 pi over 3. So x equals pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. Right, let's go to letter C. You can tell that this is going to be one of those quadratics where I set it equal to 0 and I factor it. So I'm going to move all this over to the other side, because you always have to have quadratics set equal to 0. And I'm going to let x equal the cosine of x. And then I can rewrite this as 2x squared minus x minus 1. And then I factor it. The only way to get 2x squared is 2x and x. The only way to get 1 is 1 and 1. And I need these to be negative, so one sign is going to have to be plus and the other minus. So I need to check these. 2x times negative 1 is negative 2x. 1 times x is 1x. And I get negative 1x, which is what I wanted. So my factoring is correct. Now I put cosine of x back in. And then I'm going to have to set each of these factors equal to 0, because one of them has to be 0 in order to get a product of 0. So I've got 2 times the cosine of x plus 1 equals 0. Let's start with that one. I'm going to subtract 1. 2 times the cosine of x equals negative 1. Divide both sides by 2. Cosine of x equals negative 1/2. So x is the inverse cosine of negative 1/2. Because it's cosine, x coordinate, negative 1/2. X coordinate, there's 1/2, but I need negative 1/2. Oh, there it is, at 2 pi over 3. Here it is again at 4 pi over 3. So x equals 2 pi over 3 and 4 pi over 3. But I still have to set this factor equal to 0. I'm going to do that right here. Cosine of x minus 1 equals 0. Add 1. Cosine of x equals 1. So x is equal to the inverse cosine of 1. Where is my x coordinate? 1. Right there. And this has two names, 0 and 2 pi. So x equals 0 or 2 pi. Okay. Now I've got my different graphs that I'm going to be looking at. I'm going to be looking at graphs for inverse sine first. And remember, normally for sine, the y-axis is negative 1 to 1. So the x-axis, I'm going to make this negative 1 and this 1. And for the y-axis, I'd go between, remember, inverse sine, we just look at this side. It goes from pi over 2 to negative pi over 2. So I'm going to make this pi over 2, and this negative pi over 2, and my curve goes from here to here, like that. And remember, the rest of my sine curve would have gone like that. This is, remember, the inverse, so x and y are switched. So my domain goes from negative 1 to 1. My range goes from negative pi over 2 to pi over 2. Odd or even? Odd means reflect it over the y-axis. Even means rotate it around the origin. This is even. Let's get that graph on the right. Now let's go to inverse cosine. And so for inverse cosine, I remember that I'm only looking at the top of the unit circle that goes from 0 to pi, which would normally be my x-axis, so now it's going to be my y. I'm going to call this pi. And my y-axis is usually negative 1 to 1. That's going to be my x-axis. Remember, x and y switched. And so I get down like that. My domain for my inverse cosine is negative 1 to 1. My range is 0 to pi. And this looks like it's neither. If you were to reflect it, it wouldn't match up. And if you were to rotate it around the origin, you can't. So this one's neither. Tangent. Remember with tangent, inverse tangent, I should say, only looking at this side. And we're calling this negative pi over 2 to pi over 2. And I'm going to go ahead and I'll put my pi over 2 here. Normally my pi's are on my x, but because this is the inverse, they're on my y. And I've got my asymptotes at my pi over 2's. And I always bend towards the asymptote. My domain is all reals. My range goes from negative pi over 2 to pi over 2. Notice that I didn't put equal to because of the asymptotes. And this would be odd, rotated around the origin. After reading this problem, we're asked to find the distance from A to B, which means I need to find x and y. This is 45 and this is 52. The angles in a triangle add up to 180. So 45 plus 52, subtract that from 180, I get 83. Vertical angle theorem tells me that this is 52, this is also 52. And then I can find this missing angle, 52 plus 40. Subtract that from 180, 88. So I need this distance here, and I need this distance here. So when I have all the angles, I can use law of sines. This is the one that I have, this is the one that I need. So I'm going to say sine 52 degrees divided by 400 equals the sine of 83 degrees divided by x. Got to make sure my calculator's in degrees. All right. I'm going to cross multiply 400 times the sine of 83 degrees equals x times the sine of 52 degrees. Solving for x, so divide by the sine of 52. And I'm going to put that in my calculator. 400 times the sine of 83 divided by the sine of 52. And I get 503. Does it say what to round to? It doesn't. Let's go 2 decimal places. 503.82. X equals 503.82. Now I need to find y. So again, I'm going to look at the angle in the side that I have, which is this one here. And then I need this one. So I'm going to do the same process that I did on the left side. So I've got sine of 52 degrees divided by 390 equals sine of 88 divided by y. So I'm going to cross multiply, and I get sine 390 times the sine of 88 equals y times the sine of 52. Solving for y, so divide by the sine of 52. Put this into my calculator. 390 times the sine of 88 divided by the sine of 52. 494.62. and add these together, and you will get your